Okay, what are these ratios? 1.45? And what? 1.40? Okay. If this was 0.96, would they be closer? Did everybody, or at least the majority, get 0.94?
Yeah, I think where the problem came from is that the y value on the first one is actually 1.15, and I rounded wrong.
Ah.
And I told you that.
Aha, so now we know who the culprit is. But she admitted it, so I don't know, let's vote. Should we forgive her? Okay, most people are saying yes. It's a split decision here, but you're forgiven. Now really, it's not on you, it's on everybody else who wasn't keeping an eye on us, right? Everybody's got to keep an eye on everybody. That's how we make progress. Not that anybody needs to be paranoid, we do this politely and, you know, collegially, but we say, I don't know about that, let's check it out, right? And then we come to a conclusion, and maybe we don't make a horrendous error like this. It's okay. All right? Okay, well, yeah, they should have come out a little closer. And if you do this exactly, they are exactly the same. Okay? And we could write it out exactly. We're not going to do that just now, but maybe we will. So what are the exact? These aren't exact, but for an exponential function, if you have equal partitions, these ratios will all be the same. That's a property of exponential functions. So anytime you have a sequence of numbers that are all in the same ratio, you know, the next one's always the same ratio, you know, same multiple of the one before it, you have exponential behavior. Okay? And that's a great big deal. Okay? So exponential behavior each number in the same ratio to its predecessor how many syllables? Predecessor, 4 syllables. Can you all handle 4-syllable words? Of course you can. Okay. To its predecessor as any other. Does that statement make sense? Do you see it here? If you divided this into 10 subintervals, which you could easily enough do, okay? Do you think you'd get the same ratio? Yeah, the ratio would have to be smaller, right? Because the numbers don't differ by that much. You know, because these numbers are, you're still going to have to go from here to here, but you have to do it in 10 steps in one way or another. So the numbers are going to change by less and less, right? Okay? But that doesn't necessarily mean the slopes will, because this number gets smaller as well as the rise gets smaller and the run gets smaller, right? So I would leave that as an open question. Probably ask you to investigate that. Okay?